Okay, now we're going to talk about torsional pendulum. We have a disc that is suspended by a wire, and we can see that this wire can be twisted. Okay, and it's twisted through an angle theta max here. So what will happen is when this disc gets twisted, it's going to start oscillating between plus and minus theta max. So this is going to be the direction of the positive angle, let's say. All right, so let me note here a disc that is suspended with a wire. The wire is twisted through an angle theta. Okay, so just like the spring mass system, we have in this case a restoring torque instead of a restoring force that's going to act on this disc. So we're going to see that the wire will respond to my twist by exerting a torque minus kappa theta. So in which direction is the torque going to be? So if this is my y-axis, it's in minus j hat direction, right? Because my angle is increasing to the right on the figure. My right hand tells me the omega that I am introducing is in plus j hat direction, and therefore the torque that is going to resist this increase in the angle will be in the opposite direction, in minus j hat direction. So this will be equal to I alpha, which is I d squared theta dt squared theta double dot, where alpha is defined to be positive in plus j hat direction. So I will find that theta double dot is equal to minus kappa divided by I times theta. That's my equation of motion. Once again, what is this kappa? Kappa is called the torsion constant. So it depends on the material the wire is made up of, and it's just like my spring constant in the spring mass system. So I've obtained this equation of motion, and it is already in the form of simple harmonic motion equation of motion minus omega square x, simple harmonic motion. I can recognize that my omega for these oscillations will be equal to square root kappa divided by I, which is 2 pi divided by the period, or period will be 2 pi square root I, moment of inertia, divided by kappa. So what is interesting here is that this maximum theta maximum, can be any angle as long as the elastic limit is not exceeded. What does elastic limit mean? If you twist the wire too much, you're going to cause a damage to the wire, and it will be an irreversible damage. We call that plastic deformation of the wire. If the wire is not twisted too much so that it is reversible, then this torsion constant kappa is going to be applicable, and we will have the restoring torque. So torque equals minus kappa theta is called the restoring torque. So it is analogous to the restoring force in the spring mass system.